Welcome to my channel Worldwise. What's something people don't know about the Channel Tunnel? Beneath the grey, restless waters of the English Channel lies a marvel of human achievement, the Channel Tunnel, or Channel. Hidden from view, this engineering wonder quietly connects two nations, bridging a gap that once seemed insurmountable. Stretching over 50 kilometers, it's the world's longest undersea tunnel, linking England and France beneath the sea. This remarkable passageway is a feat of vision and determination, a testament to what's possible when people dare to dream big. For centuries, the channel was a formidable barrier. Now, high-speed trains glide beneath it, connecting cities and families in ways once thought impossible. Journeys that once took hours by boat are now completed in mere minutes. The tunnel is more than concrete and steel. It's a symbol of collaboration, ingenuity, and the shared hopes of two nations working side by side. Before its construction, travel across the channel was at the mercy of unpredictable storms and thick fog, often leaving travelers stranded or delayed for days. Now there's a reliable all-weather link that operates day and night, no matter the season or the weather outside. The channel has transformed not just travel but also trade, tourism, and even the way people think about the distance between Britain and Europe. Imagine, for thousands of years, the channel defined Britain's identity, a natural defence, a psychological boundary, and a symbol of separation from the continent. Crossing it was once an adventure filled with uncertainty. Now, it's a routine part of daily life for millions. The tunnel's creation was a story of persistence, overcoming decades of political debate, financial hurdles, and immense engineering challenges. Carved deep beneath the seabed by thousands of hands and immense machines, it stands as a testament to human ambition, resilience, and the power of international cooperation. The Channel Tunnel connects not just places, but people and their futures, opening new possibilities for generations to come, and reminding us that even the greatest barriers can be overcome. For over 8,000 years, Great Britain has been an island, its history shaped by the English Channel, a busy, treacherous stretch of water. The Channel fostered a unique British identity, serving as both protector and barrier. It kept Britain separate from Europe, fueling rivalries and distinct cultures on either side. Crossing the Channel was once a foreign journey, the water a frontier of conflict and competition. Yet the dream of a fixed link, of bridging this ancient gap, persisted for centuries. Engineers and visionaries imagined connecting the island to the continent, transforming trade and diplomacy, but the sea was a powerful adversary and the technology simply didn't exist. So for generations, Britain and France remained tantalizingly close, yet worlds apart. Only a revolution in thinking and technology could finally bridge this divide. The Channel Tunnel would turn a centuries-old dream into reality. The idea of a tunnel beneath the channel is older than you might think. In 1802, French engineer Albert Mathieu Favier proposed a tunnel for horse-drawn carriages, complete with an artificial island halfway. But wars and politics doomed early dreams. In the 1880s, British and French teams began digging, but fears of invasion halted progress. The partially dug tunnels were sealed, and for decades the idea was revived and abandoned in cycles. Economic depression, war, and technical challenges kept the dream out of reach. Yet each failed attempt taught engineers more about the channel's geology and the challenges ahead. Digging through chalk was possible, but the risks were immense. What was needed? Political stability, economic strength, and a leap in technology. The groundwork was laid, literally and figuratively, for a future generation. The vision endured, waiting for its moment. After 2 world wars, Europe sought unity, not division. In the 1980s, British Prime Minister Margaret Thatcher and French President François Mitterrand saw the Channel Tunnel as a symbol of partnership and economic growth. Advances in technology, powerful tunnel boring machines, computer modeling, and laser guidance made the project feasible. Unlike past attempts, this tunnel would be privately financed, with banks and investors betting on its success. In 1986, the Treaty of Canterbury gave the official green light. The Eurotunnel Consortium was granted the right to build and operate the tunnel for 55 years. The dream was now a plan, and the stage was set for one of Europe's largest construction projects. Engineers and planners on both sides prepared for the monumental task ahead. The Great Dig was about to begin. The channel tunnel's design was ingenious. 3 parallel tunnels, each meticulously planned to serve a unique purpose and maximize safety. 2 of these tunnels were dedicated to high-speed trains, while the third, a central service tunnel, provided vital access for maintenance and emergency response. The route was chosen after extensive geological surveys, selecting stable chalk marl beneath the channel, a rock layer ideal for tunneling, naturally resistant to water and easy to excavate compared to harder stone. The tunnel would curve gently beneath the seabed, reaching an astonishing 75 meters below the seabed at its deepest point, far from the reach of tides and storms above. To carve this path, 11 colossal tunnel boring machines, known as TBMs, were constructed, each a mobile factory stretching over 200 meters in length, bristling with technology. These machines were assembled and transported to the tunnel site, ready for the immense challenge ahead. At the front, a massive rotating cutting head chewed relentlessly through the chalk while conveyor belts snaked behind, swiftly carrying away tons of excavated spoil to keep the operation moving. Behind the cutting head, robotic arms worked in unison, placing precast concrete segments with precision to form the tunnel lining, each segment sealed and waterproofed to protect against leaks. Crews worked in shifts, 24 hours a day, 7 days a week, guiding these mechanical giants inch by inch beneath the sea, monitoring every movement from control rooms. The TBMs were marvels of engineering, blending raw power with delicate control systems, combining brute force with precision, ensuring the tunnel stayed on course. Every meter gained was a victory over geology, engineering limits, and the unknown beneath the channel. The 3-tunnel system set new standards for safety, efficiency, and international collaboration. This was tunneling on a scale the world had never seen before, a true feat of human ingenuity. The journey beneath the channel had begun, marking a new era in engineering history. Life inside the TBMs was tough, cramped, noisy, and dangerous. Crews faced constant risks: high-pressure water pockets, unpredictable geology, and the ever-present threat of flooding. Engineers probed ahead, sealing fissures with grout to keep water at bay. The volume of excavated chalk was staggering, millions of tons. On the French side, spoil was pumped into a lagoon. On the British side, it created Samphire Hoe, a new nature reserve. Progress was measured in meters per day, each one hard-won. The work was repetitive, stressful, and relentless, but the sense of purpose was strong. These miners weren't just digging a tunnel, they were making history. Their skill and resilience drove the project forward. Every day brought them closer to connecting 2 nations. The Channel Tunnel was taking shape, deep beneath the waves. As British and French teams tunneled toward each other, precision was everything. Every calculation, every measurement, and every decision mattered, as even the smallest error could have spelled disaster deep beneath the channel. Advanced surveying, satellites, and laser guidance kept the machines on course. Teams worked around the clock, constantly checking and rechecking their progress, determined to meet perfectly in the darkness below the sea. The service tunnel was first to connect. The final meters were drilled by hand, not machine. It was a tense, painstaking process as workers chipped away at the last barrier separating 2 nations. On December 1st, 1990, British miner Graham Fagg and Frenchman Philippe Cazette broke through, shaking hands in a moment broadcast worldwide. Their handshake became an instant symbol of international cooperation and human achievement. For the first time in over 8,000 years, Britain and Europe were physically linked. The channel, once a barrier, was now a bridge uniting people and cultures. Cheers echoed through the tunnel, a symbol of unity and achievement. Workers from both sides celebrated together, proud of what they had accomplished. The main railway tunnels soon followed, with TBMs buried or dismantled underground. The massive machines had done their job and now became part of the tunnel's story. The raw tunnels were ready for transformation into a modern transport system. The next challenge was to turn these rough passages into a safe, efficient railway. The breakthrough was more than engineering, it was history in the making. It marked the start of a new era for travel and trade between Britain and Europe. The world watched as a centuries-old dream became reality. News crews and onlookers shared in the excitement, witnessing a feat once thought impossible. The Channel Tunnel was no longer just a plan, it was a living link. Trains would soon connect cities and people on both sides of the channel. The final phase, fitting out the tunnels, was about to begin. Teams prepared to install the systems that would make the tunnel safe and reliable for generations to come. The hardest part was over, but the work was far from finished. The spirit of determination and collaboration would carry the project through to completion. With the breakthrough complete, the focus shifted to transforming concrete tubes into a high-tech railway. Tracks, signaling, power and ventilation systems were installed, along with cross passages for safety. Fire detection and suppression systems were state-of-the-art, and shuttle trains were designed for rapid evacuation. Safety was paramount, earning the tunnel an excellent operational record. On May 6, 1994, Queen Elizabeth II and President Mitterrand officially opened the Channel Tunnel. Built by 13,000 workers over 6 years, it cost £9.5 billion and used over 3 million cubic meters of concrete. Today, Eurostar trains whisk passengers between London, Paris and Brussels in hours. The tunnel operates around the clock, carrying millions of vehicles and freight each year. It's a vital artery for travel and trade, reshaping the region's economic and social landscape. The Channel Tunnel has made Europe closer than ever before. The Channel Tunnel is hailed as one of the 7 wonders of the modern world, a title it truly deserves. It pushed the limits of engineering, logistics, and international cooperation. The precision of its construction remains legendary. The tunnel has brought the UK and Europe closer, fostering cultural exchange and economic integration. It's a symbol of what's possible when nations work together. Its legacy is not just underground. Samphire Hoe, created from excavated chalk, is now a thriving nature reserve. The tunnel has connected coastlines and created new landscapes. It stands as a testament to vision, collaboration, and innovation. Every train beneath the waves carries the spirit of those who built it. The Channel Tunnel is a bridge to a more connected future. Check out my next video. Watching now.